Good evening, all of you. This is Siddhartha Addi, and welcome to ML Ticket. Here we are going to learn machine learning through machine learning projects, and we have started our session yesterday, and we have looked upon some of the course we are going through, and we are going to do some new stuff today. Okay, so let me just present my screen and start right away. Hope that you can see my screen. So today our class is about data visualization. As I said earlier, the machine learning concepts are more important than the code. Okay, so we are going to start with the very basics, and we slowly get into the code. Okay, so let's start with the basics first. Okay, so data visualization. I hope that you all can hear me. If you have any kind of problem, just speak up because I'll be presenting my screen and I cannot look at the chat right now. So if you have problem, just speak up. Okay. Okay, let me just continue. Okay, so data visualization one. Machine learning projects can roughly be divided into three main categories. Whenever we are doing a machine learning project or any kind of machine learning problem statement that we have, that problem statement can be roughly divided into three parts. And this is very necessary to understand because these are the one of the core basics of machine learning and AI. Okay, so what is the first step? That is data visualization. So the first step in a machine learning project or a machine learning problem statement is data visualization. Next is data pre-processing. And the third one is machine learning algorithms. Let me tell you one thing. This machine learning algorithms is the most easiest part of this genre. Okay, because once you have a clear knowledge about clear knowledge of data visualization and data pre-processing, this machine learning algorithms will not be a problem. So today I am going to talk about visualization and also about pre-processing a little bit, but I will be talking about pre-processing in a greater sense when we will start our pre-processing. So let's start with the data visualization. So data visualization and why it is important. Let's imagine. Okay, one thing that you should remember that all the core concepts come from our daily life. Okay, our from our daily life, all these inspirations have been taken and they have published and made those concepts into this made those concepts. Okay, so it's a very good process so that you can learn these core concepts just if you can imagine a real life situation. So just by imagining a real life situation, everything that we are learning becomes very easy. So I will help you imagining that situation, but once you get the heck of it, you will be good to go. So let's start imagining. So imagine that you are in a market and you buy some veggies for your dinner. You pick up the best veggies just by looking at it. If it looks fresh, it has a higher probability that it is good. So when you are in the market and you are shopping for some vegetables, so the first thing that comes to your mind that the vegetable should look fresh. If the vegetable does not look fresh, you don't buy it. That's the bottom line. Okay, maybe we are not arguing about the fact that it looks bad but it tastes good. That's a different thing. I'm not arguing about that, but the common thing is that if it looks fresh, it has a higher probability that it is fresh. So this is the uh, important part. Okay, this is why visualization is very important. Visualization is very important for our learning also. Why it is that? Visualizing what we are learning is an effective way of learning, and it improves our understanding. We sometimes observe things while visualizing which we don't or can't see by just looking at the number. I have given you an example yesterday about an apple, that how you learn the first syllable of the first alphabet of the English language, that is A for apple. Apple is placed in front of you, and somebody said A for apple. So whenever you imagine A, you start imagining an red apple, and that's how your brain remembered and understood that particular alphabet. So, in the similar sense, when we are teaching a machine, we also want our machine to see those things, see those observation, make those observations, so that it can learn better. So, but here we have also have to understand one thing, that visualization not only is only for machines, but it is also for human beings. Because if you are given a random number, okay, if you are just given a random number, then it is very unlikely that you will understand anything. Okay, because our brain cannot translate decimal points very fast. Even and if we are given thousands of numbers, then our brain just hangs in there. It can't understand. But if you can draw a graph out of it, our brain can instantly understand the relationship of that graph, the pattern of that graph, what kind of the graph it is, what kind of observations that we can make. Our brain can easily understand that. So that's why it is very important for us to visualize. We will see this in the practical code today also. So let's just see for what are the few points that I have mentioned. So when we are young, we have learned everything by observing things, and we learned it well. As I said, Jay, that Apple example. Our model is like our child, and we need to teach the necessary things so that it can survive the world. So you should consider your model as your younger brother, or some beloved beloved child, so that you can feel a connection towards it. You should feed data, you should feed it information to it, so that it can understand it well. If you feed it random data, it won't be able to understand. Okay, it's just like a child. And why should we visualize? We should learn to visualize because it's just fun. Because as we will see, that visualization is way more cooler than we think it is. Okay, so let's just get to the code. I would ask all of you to open your Colab, open your notebooks, and I hope that you have written these 4 lines of code that we started yesterday, and we are good to go, I guess. Let me just upload the file, and it will also give you the time for you to connect along with me. I would always suggest you to code along with me, because if you start coding along with me, you will understand where you will when you will understand every bit of it, and if you make any mistakes, I can right away clear it out. It will take a little bit of time to upload. It won't be long. As I suggested, that this is the only problem with Google Colab, I would say. Every time you are opening the existing project, you have to re-upload the CSV file for it to work. But we can get over it, I guess. Okay, we are done. I guess uh, we can start now with our code. Okay, so I gave you a very basic understanding that why visualization is important. I have seen many coders online who skip this visualization part. But as a beginner, as a also as an intermediate or an expert, I always suggest people to visualize the data because it will give you some insight into the data that you can never imagine. Let's understand that why I am looking saying this. Sorry. Okay, matplotlib as PLT. Matplotlib is a library of Python, as I said. It is used for plotting graphs and all. We'll be using this. For some of you, people may start coding in Jupyter Notebook. For only those people, I am writing this line. I have commented this line. Matplotlib won't work in Jupyter Notebook unless and until you write this particular line. Okay, you have to write this particular line for it to work in Jupyter Notebook, but in Google Colab you don't need it. I'm going to use a specific style for Matplotlib because we are in Google Colab and I've tried and I've made many trials and error, and I've sensed that this is the most it is a good background. It gives a good background, I guess. You will understand why. Okay, we have a problem. We have our first error. What is this? Rectangle objects has no property bin. Let's see what can we do about it. Okay, it's not bin, it bins. I guess that solves the problem. Yeah. Okay, I'll give you a 30 seconds to write the code and write the code by yourself. And by that time, I'm going to explain the few lines that I've written. So matplotlib is, I have imported the matplotlib as PLT. I'm using a style known as 538. If you are coding in uh, Google Colab, I would suggest you to use this particular style because it makes the graph easier to see. Okay, it is easier to see the graph if you use this particular style in Google Colab. Other than, you can use any kind of style that you want. I personally like this particular style. Okay, so housing.hist. What is hist? Hist is known as histogram. In school, in class 10th also, you have learned histograms. You remember that rectangle boxes, rectangle things that you have used to draw. Those are the histograms. What are the bins? I would like you to experiment this part with particular this attribute, and I need you to tell me, Jay, what is this actually thing? Just change the number. To change this number to a random number and see what happens. You will understand, but it won't be. It is not something directly related, so that's why I am not very concerned about it. Be 50 is a standard number, but if you decrease the number by something to 2 or increase the number to 100, see what happens. Then you will understand what is this means. Figure size is just the figure size. I have used 20 by 15. You can use any fair figure size that you want. This is not the main concern of our. These everything under this bracket is optional. If you just delete it, it will work the same. Okay, I just prefer to have this because sometimes it helps. Okay, so let's see what we have here. Okay, we have a histogram about our data. Now you have to understand, you have to start understanding what the graph tells you. It is very important for everybody to understand that what the graph of a particular attribute tells you. Every graph tells you a story, and you have to understand that story. Okay, as an ML engineer or anything, you should understand that what is the graph is actually saying to you. Okay, so let's see. Previously, we have seen we have many attributes like latitude, longitude, latitude, housing median, total rooms, and all other. Okay, but as you can see, I have yesterday also noted that ocean proximity is not a integer or a float value. It is some kind of an object or a string. Okay, so as we know that we cannot plot a string, right? So if I just draw your attention here, can you see any graph named ocean attribute, ocean proximity? Hmm. I don't see any graph with named ocean proximity. There are only 9 graphs, but there are 10 features, right? But then why ocean proximity is not here? Because ocean proximity is an object type or a string type, and strings cannot be plotted. Okay, that's why we have not it has not plotted that ocean proximity. It is smart enough to understand that the value is not float or int. That's why it is not going to plot it. Of course, we will be looking at it in a very closely when we start concerning ourselves with that particular attribute, but not now. So let's look at it. What we have here? We have longitude and latitude. These are the two graphs that you should not be concerned about much, because these are just the latitude and longitude and does not tell much about the project. Then let's start with the first one. Okay, housing median age. Okay, so these are the numbers that as you can see, this y-axis is the numbers and 10 axis is the age, that is 0 age, 10 age, 20, 30, 40, 50. Okay, I would like you to suggest that this is some kind of abnormality is going in this graph. That is, at 50, the graph is like skyrocketing high above 1200. Okay, that is an observation that I made. Okay, total rooms. Okay, this is quite good. I can understand this. I can understand very well. Okay, total bedrooms seems fine. Total population also seems quite fine. It's a normal graph. Total households is also fine. Median income. Okay, let's see what we have here. If you can see, J, the x-axis is 0, 2, 4, 6, 10, 12, and 14. Now think about it. These are some common machine learning projects are mostly about common sense. So think about it. 2000. 2 means what? 2 means, what do you mean by 2? 2 means $2. 2 means $200. 2 means $2,000. What does it mean? Do you know? Do we know that what actually this 246 means? It can be $2. But think about it. Somebody's monthly income is $2. It's like having your monthly income as 2 rupees. Though it is not correct, I know, but imagine that. That cannot be right. So you have a common understanding that, okay, maybe 2 represents some 200 or 2000 or something, 2 lakhs. So from here, the first thing that comes to your mind, if 2 represents 200, let us assume that 2 represents 200. Why it is written as 2? We can write 200 right away, right? Why didn't it write 0, 200, 400, 600, 800? Why not? Why not? Why did it write 0, 2, 4? Why? You go to your boss and ask your boss, what is this thing? I'm very confused about that. What is the metric of this particular housing median, housing median income, sorry. So your boss look at it and say, okay, your boss says, okay, actually, you know what, this data is pre-processed data. You are like, what? You gave me a pre-processed data. Now, all of you are thinking like, what is a pre-processed data? This is the first time I'm hearing to this. So let's get back to what is a pre-processed data. I am going to give you a very slight introduction, because pre-processed data is pre-processing is a very huge part, and we will be covering it. But if you don't understand what is a pre-processed data, we will have problem. Okay, data preprocessing and why it is important. Let's say, now again imagine, start imagining. Now you have bought yourself some vegetables and now you need to eat them. That's why you bring buy things right there, because you can eat them. So but do you start eating them right away, like raw? You don't eat them raw, though it contains more nutrients. I understand that. I mean, you can argue that okay, raw vegetables may contain more nutrients. I can understand that, but do you eat them raw? Do we eat them raw? We don't eat them raw. We always cook our vegetables before we eat. In the same way, we can also say, I can also rephrase that particular sentence, that we pre-process the uh, food or vegetables before we eat. It is very important for us to pre-process the data so that we can eat, so that our body can absorb those nutrients. Otherwise it won't absorb the nutrients and you will get a bad stomach ache. Okay, so this is why pre-processing is important. Now we have to understand why pre-processing is important for our model. In a similar way, we don't want our model, which is still a baby, huh, to have raw veggies, that is raw data. So we need to cook them or pre-process them before we start feeding them in. We have to, this is a very, very critical thing that you should understand. Many people, even when I was a beginner in this machine learning, I used to get the data set, and I directly used to put the data set inside the machine learning models, and I was not getting a good output. I was not getting good accuracy. I was thinking that why I am not getting accuracy, because I was feeding in raw data. If you start feeding in raw data, it won't be able, your model won't be able to digest or understand the data properly. It won't be able to absorb the data properly. That's why it is very important for you to pre-process the data. So if we don't pre-process the data, the final yield will not be up to the mark. Pre-processing the data is very essential. Sometimes data sets come with the data pre-processed. I want to draw your attention to this last point, that sometimes data sets come with data pre-processed. Okay, so let's get back. So we come to know that income, this particular income is a pre-processed data. So the data set already contains a pre-processed data, and this is not rare. Let me tell you this: when you are working with data sets, when you are working with numerous types of data sets, it is very common for you to get pre-processed data, because the raw data is in such a scale that it is not possible for you to it is not possible for anyone to give you the raw data, and at some points it is very irritating to clean all that raw data. So some of the data comes pre-processed. So here we can understand, here we get the first glance that the data we have is pre-processed data, right? Another is this housing median value, right? So this housing median value is also, we have some kind of a abnormalities here, that at 50,000 mark it's like skyrocketing high. What is this thing? So let's understand one step at a time. Okay, as I said yesterday also, Jay, at every point we have to make observations, and every observations that we make, we are going to imply them, or do them, or code them up, so that it can be of some help to our machine learning project. So let's get things straight. First things first. Okay, first, the median income attribute does not look like it is expressed in USD or US dollars. So the after you check with your boss, he tells you the data is pre-processed. The data is scaled down. The data is scaled down to 0 to 15. Okay, this is the thing that you should be very concerned about. These are the things that you should pay very attention to when you are whenever you are looking at the data set. These are the things that you should be looking to. Look, if I sorry, if if I just show you the data, here is this median income. If I just show you these numbers, you won't be able to understand what is going on. But the moment you see the graph, you get an insight. Okay, so we have a problem, we have a caped data. Okay, I have used a new term, right? Caped. What is this caped? Caped is also a term that we can use for what do you say? Scaled data. Scaled data is also known as caped data. CAPPED, caped data. So working with pre-processed attributes is common for machine learning, and it is necessarily not a problem. But you should be try to understand that what is going on right now. If I can draw your attention, Jay, this median median age is also to some extent capped, and also the median house value is also to some extent capped. So these are the things that you should be concerned about. Now, let me tell you one thing. The most important thing that we should, as we know that at the end of the day, we have to predict this median house value. So let's look at it in a good way. Okay, let's give it a little bit of attention. It requires a little bit of attention. So think like this. The data set contains 20,640 data points. Okay, so the data is strictly limited between 0 and 50,000 or 5 lakh, sorry, 5 lakh, 0 to 5 lakh. So basically, the data is telling me right now that every house within that territory is exactly priced from 0 to 5 lakh. Does this sound normal? Can you ever determine the value of this house with this precision? Nobody in this world can determine the value of a house with this precision. What does it means? It means, J, we have a problem here. J, if the value of the house goes beyond 5 lakh, we don't have any data representing it. This is a problem, and we have to handle this problem, and we will be handling this problem. That's why at 50,000 mark it's skyrocketing high. Everything which is goes beyond 50,000 is just capped down to 50,000 mark only. That's why there is nothing after 50,000. That's why it is skyrocketing high. That's why this median housing median is also skyrocketing high at the age of 50. So you are telling me that after the age of 50 everybody dies, and everybody has to die after 50. If nobody dies after 50, they will be killed. And is this the system that is going on? It is not the system that is going on. People may live up to after age of 50, but those people's data are capped to 50 mark. That's why at 50 mark it is skyrocketing high. You have to understand these things. That's why these things are a little bit abnormal to your understanding. So what we can do about it? We can do two things, necessarily two things, but there is always a third way out. So let me tell you the both ways. First is proper collect label for the districts whose labels are kept. That is proper provide the data after 50,000 also. Ask your boss or team to provide the data after 50,000 also. You can then work easily. Other than that, if you don't have the data, then delete the entire 50,000 mark. delete the entire 50,000 mark data so that you have a good model. But it is not wise to do either of those, because at real life situation you won't be giving people won't be giving you data after a certain point, and if you delete data, of course you are reducing the nutrients in your vegetables, and as you reduce the nutrients in your vegetables, the DHA level in your model or your child will decrease, and it won't be showing a good enough results in his exams, right? So these are not a good idea to go for this. Okay, I so I'm just giving you a little bit minute, little a minute for you to understand and absorb everything. Another thing that I want to draw your attention to, Jay, let me just pull up my epic pen. Okay, so if you can see, the graph is like this. Graph is like this. This graph is also like this. So that so here you notice you notice something, that every graph that you are looking to is okay, like this only. Sorry, sorry, like this only, right? So what is the thing? What is the deal with it? Let me tell you this thing. People who are not from statistical backgrounds, or who have a good knowledge of graph, they won't be understanding this technical term, but it is crucial for you to understand. That's why you should understand this. You have to understand this. Let me just draw us a graph. This is a graph, x-axis, y-axis. Our machine learning models, any kind of machine learning models, love to have a bell-shaped curve. Bell-shaped graph. What is a bell-shaped curve or a graph? This is a bell-shaped graph. Our machine learning models always love this kind of graphs. Whenever the data is like this, they just love it. They understand more. Okay, but we don't have a bell-shaped curve here. We have what we call as a tail-heavy curve. This is a tail-heavy curve. This is a bell-shaped curve. A tail-heavy curve sometimes cause problem in machine learning algorithms. So these are some of the observations that you should make. So our data has tail shaped sorry tail shaped graph, or it is also known as tail heavy graph. If the data is a tail heavy graph, then we should keep this in mind, because later we have to deal with this problem. If the data is in bell shaped, then it's good to go, and it is already, the data is very good. Okay, so that's, let me just close it. Okay, so let me just go back to my presentation. Could you please repeat caped data? What does y-axis represent? Okay, okay, let me just caped data. Caped data means scaled data. Scaled data. Data which are scaled. Okay. As you can see, Jay, again I am repeating this age. As you can see that there is no age after 50. So you are saying people don't live after 50. Even if they live after 50, they are killed or something. That is not correct, right? This is not the way. So the data is scaled down to this value. That's why the data is called caped. Caped is also a term that we can use. And we will be dealing with this caped concept in a greater detail later. So first you need to understand that these data which are given you are to some extent caped or scaled. What does y-axis represent? Y-axis represent the number of instances, as simple as that. So it says at the age of 50 it has over 1200 instances. At the age of about, what do I say, about 20, it is like there are 500 people. So these are the numbers. The y-axis just represent the number. Okay, the number of instances we have. Okay, that just if you look at it, we can see our housing median income is high at from between 2 to 6. From 2 to 6 our uh, housing money, the median income of the people are high, that about 1500 and above people have this housing income in the range of 2 to 6. So if we consider, let us imagine two means $200, six means $600. Okay, let's $2,000 and six means $6,000. So the median income that most of the people's income are between this range, that 2,000 to 6,000. And as we can know that when we go higher, that 14,000, 15,000, the number of people grows less. What do we understand from here? We understand from here that this is a mediocre level housing census or data set. People are not too rich or not too poor in here. These are the things that you should understand. When every data set, every graph tells you a story, and that you need to understand that story. Okay, so let me just uh, conclude this particular part for you. So conclusion from the histograms. What are the conclusion? Histogram again. Median income is not expressed in US dollars. Next, the median income is capped. Okay. Next, housing median age and housing median house value is also capped. Okay. Dealing with the capped value. Okay. How do we deal with the capped value? I said there are two possible ways. They collect proper labels for those data. Sometimes it is not available, and remove those districts from the dataset, which is not wise. We will be using a third method that I am not talking about right now. And another thing, that attributes have very different scales. If you can look at it, if you just look at it, you can see J every attribute, the x-axis of every attribute is very different. Like somewhere it is 10,000, somewhere it is 10 lakh, somewhere it is 2. It is very different scale. It contains very different scale. And the last thing is that it is tail heavy. Okay, I have talked about tail heavy. So I would like you to read about tail heavy, this things and all. And of course, I would like you to tell me that what is bins actually uh, represent. Okay, I'm not talking about this bins right now. I want you to tell me what is this bins right now. Okay. Okay, so are we good up to now? Any problems? So hope that you people don't have any problem right now. Okay. So sorry. Today I am not going to code anymore. So that is the only line of code that we have written today. But I'm going to discuss something very important. Um, Next day we will be coding about it. Let's see, if I can find it. Okay. So I have a little 15 minutes. Okay, I'm not going to code anything today. The part of the talking that I am doing right now, I will be coding it tomorrow, so that you people have an understanding, so that I can connect with these two sessions. Okay, so let us talk about sampling. What is this sampling thing? As our test data set contains 20,640 data points, but we need to separate these two data. We have to make separate sets for our training purpose and our testing purpose. That is, for training purpose, we will be feeding the data to our model, and it will be trained and it will learn. And for our that and now for the testing purpose, we will use that testing set. Okay, we will have our testing set, and we will be using that particular set. So this splitting, how do we do this splitting? Do we just make any kind of split that we that comes to our mind? So how do we split? How do we split? What is the purpose of splitting right now? We have to understand this thing. We cannot make a random split. What this random? This is the question that we have to understand. What is the problem with random sampling or random splitting? Random thing is very interesting, to be honest. Let me talk about it a little bit. So true randomness is an NP-hard problem. For those who are not from computer science, or you are not in third year or something like that, you won't be understanding this NP-hard thing. Still, I would explain you this problem. In our world, every computer science, every problem statement is divided into a few genres. NP means uh, polynomial. The problems which are solvable are NP problems, and some of the problems are also known as NP hard problems. So just I'm not going to explain a great deal about NP hard problems. You will be reading about it in your curriculum. Just let me tell you that NP hard problems are the problems which are unsolvable. With whatever computing power you can start solving this problem will never be solved. True randomness is an NP hard problem. Now you would argue, say, I use a random function in a programming language, in Python, in Java, in C++. Those are some utility functions that your language provides, and that does not give you a true randomness. So that's a different thing. Just let me tell you. What is the risk of having a random sampling? The risk of having a random sampling is having a sampling bias. Now, what is sampling bias? Now, we have to consider a story. Let us assume that with the task you have been entitled with the task to select 1,000 people, make a survey and select 1,000 people for the survey. And it specifically says it has to be adults, and uh, only the survey should be only for males and females. Okay, so how do you do this survey? Should you just pick random people on the road and start surveying? Is that the way you should do these things? Because you may argue, yeah, why not? Because random sampling, if we randomly pick people, the survey results should be good. Let me tell you, You are thinking absolutely wrong. India has 52% males and 48% females, and if we do not choose people on this particular percentage, then we will have a risk of having. Okay, I have written a wrong English. Sorry, having a bias, and the results will be incorrect. So if you have to choose thousand random people for a survey, you have to ensure that there are 52 520 males and 480 females. You have to ensure. If this percentage is not met, if this ratio is not met, the results from that survey will be incorrect, and those results will go directly into your garbage bin and it will be of no use. It is very important for you to understand that random sampling is not a way to do these things. Random sampling during a survey or something like this, random sampling is not advised. Similarly, randomly picking up rows or data points for our training set and testing set is not recommended. Though people do it, to be honest, I also do these things, but it is not recommended. When you are going to do a full scaled machine learning projects, it is very crucial that you don't do any kind of random sampling. If you do any kind of random sampling, your model will predict some weird values that you won't be able to understand, and you won't be able to understand why it is giving such values, because you have made a basic error. The code runs fine, the output is fine, but you won't be able to understand that why your model accuracy is low. These are the reasons that I have to work behind the machine learning algorithms. Okay, that's why I'm saying the machine learning algorithm is the most easiest part of the programming, easiest part of the machine learning, to be honest. Okay, these are the things that you should be more concerned about. So what do we have? What is the solution to this? Sampling techniques. There are some sampling techniques that we have to be familiar with. I don't think that you have heard about these things, but let's start. There is something which is known as stratified sampling. What is the definition? In statistics, stratified sampling is a method of sampling from a population which can be partitioned into subpopulations. In statistical survey, when a subpopulation within an overall population vary, it could be advantageous to the sample each subpopulation independently. It is very complicated. Oh, I know it sounds very complicated. It is not very complicated. It's just like, yeah, if you have 100, you have 100 people to choose, and the male female ratio is 52 is to 48. You have to choose 52 males and 48 females. That is stratified sampling. If you are picking people by keeping the ratio in mind, that type of sampling is known as stratified sampling. That's all. Skewed sampling. If a variable has a skewed distribution for individual in a population, a larger sample size is needed to ensure that the sampling distribution has normal shape. Normal shape is also a thing that we talked about, that is the bell curve, that is also known as bell curve. Skewed sampling, I would say, is the normal random sampling that I was talking about, that you should not do. Skewed sampling is only preferable if the data set is very huge. It's huge. It contains 1 million data points. If it contains 1 million and over data points, then it is preferable to use a skewed sampling. Otherwise, if the data set is small, it is very, very crucial to do a stratified sampling. We have 20,000 for 640 data points, which is with the machine learning aspect, it is very low. It is a very small data set. That's why we will be using stratified sampling. How we are going to use the stratified sampling? We are going to see that tomorrow. Because I don't want to pressurize you guys with all this information because we have coped a lot of things today. So let me just get back to everything that we have learned today. Okay. So let back. So as you saw, I just wrote a single cell. That's all, right? That's all that I've written. I've written a single cell. I am always emphasizing this thing to you, that coding is not the important part. Understanding the thing is the important part. And from now on, you will see this kind of graphs, visuals, and you will start having fun. Of course, if you see some colorful images on the screen, your interest will be triggered. Of course, that I know that. Huh. But you have to be with me to understand everything. You will understand a very beautiful story that is running behind. So I have 4 minutes left. So let me just get back to everything that we have learned today. So first thing, J. Okay, let me just get back to the PPT so that it will be easier for you to follow. Okay. Data visualization is important. Roughly, it can be roughly divided into three parts: data visualization, data pre-processing, data and ML algorithms. We are currently talking about data visualization. Later, we will be do a extensive talk about pre-processing, about 2 to 3 sessions, complete 2 to 3 sessions for uh, data pre-processing. So don't worry. Data visualization is important because visualizing gives you an effective way of learning. You observe things better in visualization. I just want to draw your attention to that a median age, that at age 50 the value skyrocketed high, that after, and it says that after 50 nobody lived. So that's why it is important, because if you just give you 20,000 data points now, you won't be able to understand this thing. But the moment you see the graph, you get it. So that's why observing things while visualizing, we sometimes observe things while visualizing which we don't or can't see just by looking at the numbers. As humans, we cannot understand numbers, right? We understand graphs, we understand languages. We don't understand numbers as good as machines, of course. So next thing, conclusion from the histograms, that is median income is not expressed in US dollar. Everything that conclusion that we are making here will be useful, very important. Median income is not expressed in US dollars. Median income is capped or scaled. Housing median age and median house value is also capped. Dealing with the capped value. How should we deal with the capped values? There are two options: collect proper labeled data. Sometimes it is not possible. Remove those data districts from the data set. It is not recommended. I'll be teaching you another way of doing this stuff. Attributes have very different scales, and the curves are tail heavy. As I said, there is tail heavy. Some of our machine learning models do not like tail heavy. Data pre-processing. Why it is important? Because pre-processing data will ensure that the data is absorbed into the model. Okay. And what is the problem with random sampling? It is a random true randomness is an anti-hard problem. We have a risk of sampling bias. And what are the sampling techniques that we have talked about? Stratified sampling and skewed sampling. We will be starting tomorrow with just code, and though I'll be repeating this much today, that's this stratified sampling and skewed sampling tomorrow also. But from tomorrow we will start coding everything that we have talked about, all the observations that we have made today. Okay, so that's all. I'm I'm correctly at 5, so I think that's okay. So do you guys have any kind of problem? Do you have complete access to my uh, Google Colab file? Is anybody having any kind of problem? Because previously I have not granted a public access, and I have recently changed that tomorrow night. And yes, sorry, yesterday night. So if you guys have any problem, just contact me. I'll be helping you right away. and hope that you are coding along with me. I cannot see you guys right now, but hope that you are coding along with me. I mean, you can see that it is very little code, right? So you can just code along with me. You won't be having any problem. And I will be later, if problem arises, I will be posting code snippets and all. And till date, is everything clear? Because from tomorrow we are starting to code everything that we have talked about today. Um, okay. For machine learning, I would suggest Google Colab. Okay, but if you talk in general sense, I would suggest Visual Studio Code. For machine learning, I would suggest Jupyter Notebook or Google Colab. I used to run Jupyter Notebook previously, but when after the time Google Colab came, it is much easier. And another thing, when you start doing very heavy machine learning things and start using TensorFlow and Keras and deep learning stuff, so those libraries are very heavy. They are like 500, 600 MB of libraries. So it is very tough for people to download those files. And if you are downloading those files, you have to make sure that you use your GPU and CPU and all those settings and all. But in Google Colab, you can directly just import those libraries because it's already imported in Google Colab. So for machine learning, I would suggest Google Colab. For general coding, I would suggest Visual Studio Code. You can just search it out on Google. You will understand. Tomorrow we have a, what about Watson Studio? Watson Studio. To be honest, I have not heard about Watson Studio. Achha, let me just stop presenting. I have not heard about Watson Studio, but I personally use Google Visual Studio for all my developing purposes, and it is quite good, to be honest. Actually, you can use anything. You can absolutely use anything, any type of code editor that you want. You can use Notepad plus plus also if you want to code. I've also used at some points of my life. I've also used Notepad for my coding. So that's not the point. Try Spider. Yeah, you can also try Spider. This is a very good suggestion. Try Spider. You can use Spider for Python. And Spider comes pre-installed with Jupyter Notebook. So from tomorrow we are going to do some hard coding. So see you guys tomorrow. If you have any problem, just drop your question in the group. So I'll be answering you. Will you teach TensorFlow also? Look, TensorFlow is a library that is used in deep learning. Okay, um, if you if you if I do this project, it is a regression problem. Okay, if I get the chance, I'll be posting another session, another complete session about a classification problem. Okay, after that, I have to take another some of your sessions for clearing the basics of some of the machine learning algorithms and getting into slight advanced stuff. Then we can start with deep learning, and inside deep learning we can start with TensorFlow. Okay, so that is a way ahead. Okay, if you want to learn TensorFlow, that is a little bit overdue right now. TensorFlow, you can do TensorFlow. To be honest, all the libraries that I'm using are also present in TensorFlow, but it is an overkill. That is like for killing a mosquito, you are pulling up a machine gun. This is not worth it, right? So that's all. So Hope you guys enjoyed. We will be continuing this session every day at the same time. Hope you guys, you will. I will see you guys tomorrow. Thank you. You can sign off.